Hey, 7th grade, we are looking at changes in dimensions here. This is Chapter 8, Lesson 6. And I'm going to get my red pen out here so you can see what this is all about. Yep, I knew that was going to happen. I'm going to draw. It's just like I'm there in the room and everything's happening. So I want to show you what changes in dimensions look like. And you'll see most of this very familiar with what we've done before, especially in the last chapter of our last book. So here's what they're talking about these similar solids. They have the same shape and their linear measurements are proportional, which is kind of like what we just did with those similar triangles. So you see how every side of this cube, these cubes here, we have 4 to 8. Everything is similar. So the question is, what happens if you're talking about the surface area of a similar shape? And they go through it up here and they say, well, the surface area, there are 6 faces. Each one is 4 times 4. So 6 times 4 times 4. Now, on the other one, every edge is multiplied by 2. 4 times 2 is 8. So they did 4 times 2 is 8. 4 times 2 is 8. And they said there are still 6 faces, and it's 2 times 4 and 2 times 4. So then they just rearrange stuff, using the commutative property for multiplication. And you end up with 2 times 2, 2 squared. So if the scale factor is 2, what it says right here, scale factor is 2, the size goes up by doubling or by a factor of 2. And what you do is you do for surface area, you would do 2 squared. All right. Now, let me go down and show you the next part. So here they say, here is the surface area of this rectangular prism, 78 square centimeters. And then it says, what would happen if there was a similar prism 3 times as large to the surface area? So the scale factor here, 3 times, and you square it. So since you're talking about square centimeters for surface area, you square the scale factor. So it would be 78 times 9, 702 centimeters squared. So this one here, since I conveniently left the answers on for you on this one, 34 square inches and twice as large. So again, the scale factor is 2, so you square that. So on my calculator here, even though I know the answer, 2 times 2, so 2, the scale factor squared, and then times 34 gives me an answer of 136. Now this one, I like this one. It says we have this surface area of this box is 352. Similar box, smaller by a scale factor of 1/48. So again, we're going to take that 1/48 and we're going to square it. Ooh, that's fun, making a 48 there. So you're going to square that. So the top number would still be 1. And I'm hoping you're all just flying on your calculator, which you should be. And you square that and you get this gigantic number, 2, 3, 0. Yeah, that's a 0, everybody. And 4. Now, we squared the scale factor and got that. So now, looks like we do 352 divided by 2304. And so, if I 352, I get an answer of 0.153. And that's what they have here. They have 0.15. They did it like this too, but I like that better. Back to the arrow. The numbers stayed there. Yay, clear the screen. That's what that little square means. Now I understand. All right, now, if it's volume. Okay, so again, it's the same cube, and you have volume. And the volume, again, the scale factor is 2. So if you think about the volume is 4 times 4 times 4, right? Length, width, height, 4 times 4 times 4. And if you made everything twice as big, it would be 2 times 4, 2 times 4, 2 times 4. So you still have your 4 times 4 times 4, but you pull out your scale factor of 2 times 2 times 2, and you get cubed. So, if volume is cubic inches or cubic something, then where we squared the scale factor in the last one, this time we're going to cube it. Goodbye to the answers. All right. Here's their example. So you have this triangular prism here, volume of 432. It was reduced to 1/3 its original size. Volume of the new prism. Well, there is the scale factor, 1/3, and you have to cube it. So 1/3 times 1/3 times 1/3. That's 1/27th. So it's 432 divided by 27 equals 16 yards cubed. There you go. Now here we go. Let's see how we do. This was 1/4 the original 512. So let's see, 1/4 times 1/4 times 1/4. I believe that's 1/64th. So I'm going to take 512 and I'm going to divide it by 64. And I'm going to get 8. So this answer here, go back to my fancy pen of blue, and I should have an answer of 8. Oh yeah, I'm getting so good at that now. Now this one, again, 1/3. We already did 1/3. That's 1/27th. Dimensions are 1/3. So 432 divided by 27. That's 1/3 times 1/3 times 1/3. I should get 16. All right, let's turn on the answer to see how we did. If I could remember to do that. 8 and 16. There you go. Seems pretty easy so far. There is a little trick, though, on a couple that we'll get to in a minute. Let's go to the next page. And again, today you'll have a couple sheets to do, and most of it's going to be probably straightforward like that, where you square or cube the dimensions. Oh no, answers, we must turn them off. So again, you have surface area enlarged by a scale factor of 7. Now surface area, you square it. So I think this would be 35 times 49. 35 times 49, 1,715. Really? Sure enough. What do you know? Same thing here. Volume now. That means we have to cube this. 1/3, 1/3, 1/3, 1/27th. So 425 divided by 27. That's 15.74. Okay, I hope you're getting the point of this. Now, here's one where you'll have some of these, where it says the sink measures 16 by 15 by 6. And the second sink is half. So you have to find the volume and surface area. Well, the thing is, you don't know the volume or the surface area of the sink in the first place. I'm going to do the volume first because that is easier. Now, if they're giving you 3 dimensions here, that must mean that it is, I think, like a sink. It's probably kind of like a rectangular prism. And my art skills are unbelievable when I'm drawing on a Chromebook. There you go. So now we have 16. What was wrong with that? 15. Not being very cooperative right now. Let's try that one again. And then the other one was 6. Yeah, more curves because it's so easy to make curves. There we go. So first for the volume, 16. And please be doing this at the same time. 15 times 6. Now, the scale factor is 1/2. And if I'm talking about the volume, that's 1/2 times 1/2 times 1/2. That's 1/8. So I'm going to take that number as 1,440 divided by 8. and I get 180. So for the volume, the easier one, I'm going to get 180. Ooh, it does not like me right now. Let's remember that that's 180. Ooh, yeah, not even close. 1. Now, surface area, you have to think about each side. So I know I have 16 times 15. Easy for me to say since I can't type it in. 16 times 15. That's 240, and that's so times 2. That's 480. All right. And I'm going to write these down, and I'll write it on a piece of paper since I can't keep up with this with that little marker thing. Okay, that was the top and the bottom, 16 times 15. Now this side right here is 15 times 6. That would be 90, and there's 2 of those. That's 180. And then it looks like I need to do now the front. That's 16 times 6 times 2. That's 96, which would be 192. I think I got everything. I got the top and the bottom, the front and the back, and the left and the right. So I have 192 plus 180 plus 480. That's 852. Scale factor is 1/2. Now, this is surface area. So since it's area, that's squared. So it would be 1/2 times 1/2, and that would be 1/4. So I'm going to take 852 and divide it by 4. Whoops, 852 divided by 4 should be 213. Is it going to let me now? 2, 1. All of a sudden, it does not want to make it. All right, let's clear it off and see if I have 180 and 213. Let's turn on those answers. Oh, wait, go back to my arrow here. There we go. All right, 180 and 213. So you are going to need to remember how to get volume and surface area for some of this. And that's the same thing that happens on another one here, but I forgot where it went. Probably at the top of that page when I was on the bottom of that page. Yeah, up here, this was the example that I saw where it says standard hockey puck. Those are the dimensions: 1.5 inch radius, a 1 inch height. And then it says the giant hockey puck on the left is 40 times the standard. It says wants the volume and the surface area. So they give you the formulas here for the volume, which again cubed, surface area. Now remember, for their surface area thing, they're doing 2 times the area of the circles of the top and the bottom. So 2 top and bottom, top circle, bottom circle. And then this is the surface area of the height. It's the height times the circumference. So that they like to do 2 pi r instead of pi times diameter. So you could do pi diameter height and then 2 pi r squared. And then when you're done, notice they give you the answers right here, which would be great to pause this if you want to take a look at this. And then, since it's 40 times bigger, the volume, 40 times 40 times 40, gets you quite a big number. There's the volume. There it is, times 40 cubed. Get that big. Surface area, you've got that, 2355. And since it's 40 times bigger, this time you square it, and you get that. So that's what you're going to do today on those sheets. So see how you do. You have the formulas for surface area and all of that, and I think you'll do just fine. Just remember, if it's a change in surface area, you square it. If it's a change in volume, you cube it. There you go. And I'm pretty sure that's the last time you'll have to listen to me do a video for you.